Hello everyone. So this is our lecture number 3 of difference equation part first, and previously in the two videos we have seen some fundamental difference formulas and some examples. So today we will start with this two formulas, that is delta of tan t and delta of tan inverse of t. So let's see delta of tan t. So if delta is applied on tan t, what we get? Okay, so we'll first apply the basic definition of delta operator. So tan t plus 1 minus tan t, and tan अल्फा एंड tan बीटा का जो फॉर्मूला रहता है वो अपन अप्लाई करने वाले हैं. देन tan t प्लस 1 माइनस टी इंटू 1 प्लस tan t प्लस 1 इंटू tan t. ओके, सो tan 1 इंटू 1 प्लस tan t एंड tan t प्लस 1 को अपने फॉर्मूला लगाए. ठीक है, tan t प्लस tan 1 अपॉन 1 माइनस tan t इंटू tan 1, दैट इज इक्वल्स टू tan 1 इंटू 1 प्लस tan स्क्वायर t. ओके, tan square t plus tan t into tan 1 upon 1 minus tan 1 into tan t. Okay, then tan 1 into 1 minus tan 1 into tan t plus tan square t minus tan t into tan 1. What we have done? We have multiplied this with this and then solve it. Okay, so 1 minus tan 1 into tan t plus tan square t plus tan t into tan 1. So this minus and this plus will be getting cancelled upon 1 minus tan 1 into tan t as it is. Then is equals to tan 1 into 1 plus tan square t, ये 1 and tan square t upon 1 minus tan 1 into tan t as it is. Then what is 1 plus tan square t? That is sec square t. So tan 1 into sec square t upon 1 minus tan 1 into tan t, and that is our what we want. Okay, so delta of tan t is equals to tan 1 into sec square t upon 1 minus tan 1 into tan t. Then the next one is delta of tan square t. Okay, so what is delta tan inverse of t? That is equals to tan inverse of t plus 1 minus tan inverse of t. We have simply applied the difference operator here. Okay, so tan inverse of alpha minus tan inverse of beta, we have applied the formula. Then tan inverse of t plus 1 minus t upon 1 plus t plus 1 into t, that will be tan inverse of 1 upon t square plus t plus 1, and this was the answer we wanted. Okay, so we have seen delta of tan t equals to sec square t into tan 1 upon 1 minus tan 1 into tan t, and delta of tan inverse of t is equals to tan inverse of 1 upon t square plus t plus 1. Okay, now next we will see the falling factorial power. Now the falling factorial power, why this is for? We have seen in the derivatives, we have applied the product of index powers, and we are not able to do that in this difference. Okay, so we have seen something like falling factorial power, so we will use this in the difference operator thing. Okay, so the falling factorial power t to the power r to the falling, how we will read this? Read as t to the falling r, या फिर read as t to the r falling. We will not read it like this, that t to the power r underline whatever it is. We will read it like t to the r falling, या फिर t to the falling r. Okay, is defined as follows according to the values of r. So according to values of r, it is defined as these types. Okay, so first is if r equals to 1, 2, 3, that is positive integers, then t to the r falling equals to t into t minus 1, t minus 2 and up to so on t minus r minus 1 आएगा यहाँ पे. Okay, t minus r minus 1 and that will be t t minus r plus 1. This minus minus will be plus. Okay, so if r is any positive integer like 1, 2, 3, 4 and up to so on, anything, so t to the r falling will be defined as t into t minus 1 into t minus 2. एक एक टर्म्स आपण कमी करत जाऊया अप टू द r minus 1. दॅट इज इथे जो कुठला टर्म राहील, सपोज इथे सारखा 3 आहे, t टू द फॉलिंग r, ओके सॉरी t टू द फॉलिंग 3 जर का इथे असला तर आपण कुठपर्यंत जाऊया, t minus 1 t minus 2. दॅट इज 3 minus 1च्या टर्मपर्यंत. करेक्ट. r minus 1 आहे कारण इथे r आहे. इफ 3 इथे असता तर 3 इथे असता तर आपल्याला जायचं असतं t minus 1 आणि t minus 2 पर्यंत. ओके, देन सेकंड वन इज इफ r equals to -1 -2 -3 and up to so on. So if r equals to negative integer, then our t to the following r will be equals to 1 upon t plus 1 t plus 2 and up to so on t minus r. इथे जो आहे तोच इथे येईल. इथे समजा -1 असता तर 1 upon t plus 1. Okay, if here we choose r equals to 5, then what will be t to the following r, that is t to the following 5 will be equals to 1 upon t plus 1 t plus 2 and up to so on t plus 5. Okay, then if r equals to 0, suppose आपण r equals to 0 consider केलं, ना positive ना negative. If r equals to 0, then it is directly t to the following r equals, हे तर लक्षात ठेवण्यासारखी गोष्ट आहे. So r is equals to 0, then t to the following r will be equals to 1. Okay, you have to remember this. Then fourth one is if r is not an integer. If r is not a positive integer, not negative and not 0, so if not r is not an integer, then what will we do? T to the following r will be equals to gamma of t plus 1 upon gamma of t minus r plus 1. What is this? It is gamma. Okay, so r, if it is not integer, then we will write as t to the following r equals to gamma of t plus 1 upon gamma of t minus r plus 1. So this was the following factorial power. Once again, we will write the definition as the following factorial power read as t to the r following or t to the following r is defined as follows according to the value of r. If r is positive integer, then t to the following r will be equals to t into t minus 1 up into t minus 2 and up to so on up to r minus 1. That is r च्या आधीच्या व्हॅल्यूपर्यंत आपल्याला व्हॅल्यूज काढायला लागतील. देन इफ r equals to -1 -2 -3 and up to so on, if r is a negative integer, then t to the following r will be equals to 1 upon t plus 1 t plus 2 up to so on t minus r. म्हणजे जी व्हॅल्यू आहे त्या व्हॅल्यूपर्यंत जायचं आहे. ओके, t minus r. Then third one, if r is nothing but 0, not an positive integer, not an negative integer, it is if 0, then t to the following r will be equals to 1 only. Okay, then fourth one will be r is not an integer, then t to the following r will be equals to gamma of t plus 1 upon gamma of t minus r plus 1. Now we have some notes here. So first is the definition of t to the following r given only for those values of t and r that make the formulas meaningful. It is only for those values, that is t and r. If t and r making it meaningful, then only we can use t to the following r. For example, -2 to the power following -3. What we read? -2 following -3 is not defined. Why? अगर अपन उसको सॉल्व करके देखें. So what will be getting? 1 upon minus 2 plus 1 minus 2 plus 2 and minus 2 plus 3. So here we'll be getting 0. So 1 by 0, that is not defined. Okay, so therefore this minus 2 to the following minus 3 is not defined. Okay, second one is let r be a positive integer, then gamma of t plus 1 upon gamma of t minus r plus 1 will be equals to t gamma t. Why? Because gamma of t plus 1 is equals to t gamma t. Okay, and gamma of t minus r plus 1 is as it is, then equals to t gamma t minus 1 upon t minus r plus 1. Okay, and that is equals to t minus 1 up to so on t minus r plus 1 gamma of t minus r plus 1 upon gamma of t minus r plus 1. So this will be cancelled and we will remain with t into t minus 1 and up to so on t minus r plus 1. Then third one is if n and k are positive integers with n is greater than k, greater than or equal to k, then n to the following k counts the number of permutations. So if n and k are positive integers and n is greater than or equal to k, then this n to the following k counts the number of permutations of n objects taken at k at a time. Okay, this will be the number of objects and k will be taken at a time. Now we know that the number of combination of n objects taken k at a time is given by the binomial coefficients. How we read it? nck equals to n into n minus 1 and up to so on n minus k plus 1 upon k factorial. Okay, so n minus k plus 1 तक के हमें जाना है, that is equals to n to the following k upon k factorial, that is equals to n to the following k upon gamma of k plus 1. Okay, and this gives the binomial coefficients and following factorial relationship. Okay, binomial coefficients, these are the binomial coefficients and this is the following factorial relationship. Okay, now next we are going to see the definition of the binomial coefficient. Okay, so the binomial coefficient TCR is defined by TCR equals to t to the following r upon gamma of r plus 1. And when you will go through the 11th class books, you will see all these three properties. So first property is TCR equals to t ct minus r. Second one is TCR equals to t by r t minus 1 ct r minus 1. And third one is TCR equals to t minus r c r plus t minus 1 r c minus 1. Okay, sorry, t minus 1 c r minus 1. Okay, and for this we will see some examples. For that I need one paper. So the first property is TCR. Okay, TCR equals to T C T minus R. Suppose T is 10 and R is 2. So considering 10 C2 and here it will be 10 T minus R was. So 10 minus 2, that is 8. So 10C2 is equals to 10C8. So what is 10C2? It will be 10 into 9 and upon 2 factorial. So this will be equals to 10 into 9 into 8 into 7 into 6 into 5 into 1 2 3 4 5 6 7 8. So 5 into 4 into 3 and here it will be 8 factorial. So 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Okay, so from 8 to 3 this all will get cancelled. Okay, so what we get 10 into 9 by 2 into 1. So it will be same as this. So 10 into 9, that is 90 by 2, that is 45, and here 45. So these are same. So we have proved the first property. What is second one? Second one is TCR equals to T by R, T minus 1, R minus 1. Okay, T minus 1, C, R minus 1. Okay, for this also we'll consider same. So 10C2. Okay, 10C2, then 10 by 2, and here 10 minus 1, that is 9, C, R minus 1. So R minus 1 यानी कि 2 minus 1. So this will be 1. So 10 by 2, that is 5. And here what is 10C2? It is 45. Okay. So 10 by 2 is 5 and 9C1 is 9. Since 9 and upon 1 factorial. Okay. So 5 9s are 45 and here also 45. So second one is also proved. And the third one. What is the third one? TCR T minus 1 CR, T minus 1 CR and T minus 1 CR minus 1. T minus 1 CR minus 1. Okay, correct. So now we'll consider with the same 10C2, then 10 minus 1, that is 9, and 2 plus same here 9 and R minus 1, that is 1. So 10C2 is 45. Okay, then 9C2 will be 9 into 8 and 2 factorial plus 9C1. What is 9C1? That is 9. Okay, so here 72 by 2 plus 9. So 36 plus 9, that will be 45. And here LHS is LHS is already 45. So these are LHS equals to RSS. Okay, so we have proved all the three properties here, and you can also check them in the 11th standard book if you want to. Then next is first theorem. Okay, we have seen some falling factorial properties earlier, and now we will see delta operating on the falling factorial power. Okay, so the first one is delta operating on t to the falling r, where the subscript is t, that will be equals to r into t to the falling r minus 1. Okay, second one is delta operating on tcr, where t is a subscript, equals to tcr minus 1, where r is not equals to 0. The third one is delta operating on r plus t ct equals to r plus t ct plus 1. Okay, now we will see the proof. So for the first property, for this we have two cases, right? So we have two cases for it. So first case is if r is a positive integer. This r, if it is a positive integer, so what will be the case? So let's start with delta t operating on t to the falling r will be equals to, first we will operate simply delta definition. So t plus 1 to the falling r minus t to the falling r. Okay, and what will be t plus 1 to the falling r? It will be t plus 1 into t minus 1 up to so on t plus 1 minus r minus 1. And what is t to the falling r? It is t into t minus 1, t minus 2 up to so on t minus r minus 1. Okay, then t minus 1, t minus r plus 2 are common in both of the terms. Okay, so we will take it common, and what is remaining here? T plus 1, and here we will remain with t minus r plus 1. Okay, this bracket will be solved and t minus r plus 1. So next will be t plus 1, t minus 1 up to so on t minus r plus 3 t minus r plus 2. Okay, minus t into t minus 1 up to so on t minus r plus 2 t minus r plus 1. What we have done, we have multiplied this both. Okay, then what we get, t into t minus 1 t minus 2 up to so on t minus r plus 2 is common in both of this, and what we remain, t plus 1 minus t minus r plus 1. So what is t into t minus 1 t minus 2 t minus r plus 2? What is it? It is t to the following r minus 1, and here t will be cancelled and plus 1 minus 1 will cancel, so remaining is r. So r into t to the following r minus 1 is remaining. Okay, this is the same we have get. Okay, and the second one, the second case is if r is arbitrary. So if r is arbitrary, we will take r as it is. So delta operating on t to following r is equals to delta gamma of t plus 1 upon gamma of t minus r plus 1. आपण ज्या प्रॉपर्टीज पाहिल्या ना, आर इज आर्बिटरी, जर का आर आर्बिटरी असला तर आपण कसं लिहितो, गॅमा ऑफ टी प्लस 1 अपॉन गॅमा ऑफ टी मायनस आर प्लस 1. सो गॅमावरती परत डेल्टा आपला होईल. ओके, सो गॅमा टी प्लस 2 अपॉन गॅमा ऑफ टी मायनस आर प्लस 2 मायनस गॅमा ऑफ टी प्लस 1 गॅमा ऑफ टी मायनस आर प्लस 1. देन गॅमा t plus 1 gamma t plus 2 will be written as t plus 1 gamma t plus 1. Okay, असं असतं ना gamma of t plus 1 equals to t gamma t. करेक्ट. सो सेम इथे आहे t plus 2 आहे म्हणून आपण काय लिहिलं, t plus 1 gamma t plus 1. सेम then t minus r plus 2 साठी पण t minus r plus 1 gamma t minus r plus 1 and this side as it is. then t plus 1 gamma t plus 1 आहे तर t plus 1 इथे पण आहे इथे पण आहे. सो या दोन्ही टर्ममधनं आपण t plus 1 अपॉन t minus r plus 1 कॉमन काढला. ओके, आणि गॅमा t plus 1 आणि t minus r plus 1 कॉमन काढला. उरलं काय तर t plus 1 t minus r plus 1 minus 1. Okay, that is equals to gamma of t plus 1 upon t minus r plus 1 as it is. Then multiply this t plus 1 minus t plus r minus 1 upon t minus r plus 1. What is remaining? R into gamma of t plus 1. This t and 1 will be cancelled. R gamma t plus 1 and here t minus r plus 1 and gamma t minus r plus 1. So r into gamma of t plus 1 as it is, and what is this, t minus r plus 1 gamma t minus r plus 1, same like here. So what we get, gamma of t minus r plus 2. So r gamma t plus 1 upon gamma t minus r minus 2. And what is this, r as it is, and gamma t plus 1 upon gamma t minus r minus 2 will be t following r minus 1. Okay, and that was the answer. See, this was the answer. So from first case and from the second case we have obtained that. Now the next one, delta t operating on TCR equals to t plus 1 CR minus TCR. So t plus 1 CR, how we will write this, t plus 1 to the following r upon gamma r plus 1 if r is arbitrary. Okay, then minus of t to the following r upon gamma r plus 1, this is for TCR. Then 1 upon gamma r plus 1 is common in both the terms. Okay, 1 by gamma r plus 1, 1 by gamma r plus 1. So we'll taking it common, and what is remaining, t plus 1 to the following r minus t to the following r, that is equals to 1 by gamma r plus 1, and this is delta operating on t to the following r. Okay, what is remaining then, delta t to the following r into, delta t to the falling r is written as r into t to the falling r minus 1 and upon gamma of r plus 1 as it is. Then we know that r into gamma r equals to gamma of r plus 1. So for this r and this gamma r plus 1, we can write 1 by gamma of r and t to the falling r minus 1 as it is. For this, we have written 1 by gamma of r because we know r into gamma r equals to gamma r plus 1. Okay, so t to the falling r minus 1 as it is and 1 by gamma r, and we can write it like tc r minus 1, and this was the obtaining answer. Correct? So this was the answer. See, tc r minus 1, and we have obtained that. Last one is delta operating on t, r plus t c t equals to what we have, r plus t plus 1. We have applied delta. So r plus t plus 1, t plus 1 minus r plus t c t, and that will be equals to r plus t c t plus 1. Okay, this was simplest one. So till here we are done with the falling factorial properties. Okay, so next we will see in the next video. Till then, thank you.